Hi class, we are looking at the 4 laws of radiation and we're looking at law number 4, and I know that I've taken these laws out of order, that I'm covering law number 4, Stefan Boltzmann's law, prior to law number 3. And so law number 4, Stefan Boltzmann's law, allows us to calculate the total energy emitted by an object. And basically what Stefan Boltzmann's law says is that the hotter the object is, the more energy it emits. Okay? And so what I want to do is to use the sun and the earth as examples here. So we're going to take a look at the energy emitted by the sun and compare that to the energy emitted by the earth. So let's first take a look at the temperature of the sun, and the surface temperature of the sun is approximately 6,000 Kelvin. Okay, so we're working in temperature with units of Kelvin in this particular problem. Okay, so the energy emitted by the sun will be equal to a constant, sigma, times the temperature of the sun raised to the 4th power. Okay, and so if we do that equation then, so the energy emitted by the sun is equal to that constant, and the constant is kind of intimidating, 5.67 times 10 to the negative 8th, and the units on that are watts per meter squared times temperature raised to the 4th power, Kelvin to the 4th power. And we're going to multiply that times the temperature of the sun, 6,000 Kelvin, raised to the 4th power. Okay. Now notice that the 6,000 Kelvin is inside the parentheses, and the power is to the outside. That's important because that means we have to raise the number, 6,000, to the 4th power, and we have to raise the unit, Kelvin, to the 4th power. Okay, why that's important is notice that Kelvin to the, or K to the 4th is in the constant, and K to the 4th is in the temperature raised to the 4th. So the K to the 4th is going to cancel out in the end here. And so this is going to leave us with 73,483,200 watts per meter squared. Okay, so what this is telling us is that for every square meter of the sun's surface, it is emitting 73,483 watts of energy. That is a lot of energy. Okay, a lot of energy, especially compared to the Earth. So let's do an example now of the Earth. So we just calculated the energy emitted by the sun. Now let's calculate the energy emitted by the Earth. And so the temperature of the Earth, and we're going to round it off. It's actually about 288 Kelvin. But to make things a little bit easier on ourselves, let's round it to 300 Kelvin. Okay. So the energy emitted by the Earth is equal to that constant, sigma, times the temperature of the Earth raised to the 4th power. Okay, so the energy emitted by the Earth is equal to the constant, 5.67 times 10 to the negative 8th watts per meter squared, Kelvin to the 4th power, times the temperature of the Earth, 300 K, raised to the 4th power. Okay, so when you punch this into your calculator, this comes out to 459 watts per meter squared. Okay, so the Earth is emitting approximately 459 watts for every square meter of Earth's surface. Okay, so I mean, compare the numbers here. The sun's emitting way, way, way more energy than the Earth does, which makes sense because the sun is 20 times hotter than the Earth. So the Earth's average temperature about approximately 300 K. The sun's average surface temperature about 6,000 K. So it's about 20 times hotter than the Earth. Okay, and as a result, it's emitting a tremendous amount more energy compared to the Earth. Okay, so there's an example of radiation law number 4, that hotter objects emit more energy than colder objects, and we've used the sun and the Earth as our examples here. We're going to take these numbers next when we take a look at radiation law number 3, and we're going to use these numbers that we just calculated and apply that to radiation law number 3. Okay, so that's coming up next.